All right, okay. Sorry for the little delay there. All right. So more about optimal supply networks, and this is going to be this business that I call quarterology, right? So this is a crazy, crazy story, and lots of pieces. Starting in the 1800s, with people making crazy assertions about how much to feed their workers based on their size, right? Good old human, ingenuity. All right, so we'll get to that. But this is a very big story about ecology, biology, the limits to what life can produce, right, in terms of the energy that organisms use, and therefore, how they can all fit together and so on. Sort of a tangential thing, but some of you remember in Park's bit of scaling, this interesting scaling for a bad thing, cancer rates in people, and it was as a function of cell turnover for the particular area of the body where the cancer originates. And so that scaling seems to be something like the rate to the power of 2/3. It's not linear, right? It rolls over. So, and that is something I was just looking at the other day, right? So it turns out, and I'm thinking about sizes here of organisms, so whales apparently don't get cancer that much, right? And if you think about, say, mice and humans, right, we should get, right, if the cells are kind of all operating in similar ways, then we should just get a lot more cancer than them. Like whatever their rate is, we should get, factors more, perhaps. But it seems that, and this is maybe the case, so it's called Peto's paradox, I think it's known as, after a person who kind of pointed this out. The bigger organisms they seem to just have more mechanisms, right? More little algorithms, essentially, for cleaning up mistakes that happen. So we've talked a lot about, I'm just sort of going off on some stuff here, we've talked about robust yet fragile, right? This notion of a lot of systems having, especially the ones we see because they're around all the time, that they're, they last and then suddenly they can blow up, right? So ecological systems, financial systems, all sorts of things have these properties. The power grid that we've created for ourselves, and us, right? I mean, sometimes things just go, it all falls apart. But I think a lot for organisms, there's a different framing, which would be like catastrophically failing yet robust, right? Because we have like things going wrong all the time, and we have a whole, evolution has just said, hasn't done that of course, but it's just kind of come along as we've sort of made bigger and bigger things have emerged. It's like, this stuff's just going to go wrong, this is the kind of story we have, and if we get better, we're just going to have things that fix it up. So it wasn't that we made, that evolution produced better things that just work perfectly, like little machines that we would sort of make. We would make these much more robust machines that don't fail at all. Of course, we're changing how we do these things. It's that the biology seems to just kind of encompass it. Anyway, lots of interesting things happen across scales, and today it's going to be about energy. Okay, so there's an assignment one fixed, thanks to Ada, and I'm sorry about that. So it was about, here's my crazy little org thing, which I've lost control of. Where did it go? Here it is. So there's a fix here, and I guess it's over here. So this should be a 3 here, which was just a bad thing that I did. This should be 3 times the number of triangles. That's what this piece counts if you use this, and then this is the total number of triples. And the 3 has to be there because each triangle closes up 3 triples. So thank you. So that's fixed, and I uploaded it, and it's there. There is a lot of craziness that I'm developing. This is insane, but so now I'm splitting up all the lectures. I mean, this is just madness, and you can just like ignore this, I suppose, but I'm splitting up all the lectures into little pieces and uploading them separately, and I'm going to make another script that does some other things and whatever. So it's going to be a bit of a better, I think it will be a better product, but yeah. Anyway, but it's I have to say, whenever you start to turn things, and I have many, many things as scripts, but when you have something that wasn't a script and you start turning it into a script, you were doing things by hand and maybe copying and pasting, and it kind of worked. As soon as you do that, it opens up all these other possible things. You don't just do what you did before. I mean, I know you know this, but scripting is just kind of amazing to me. what you can do. You know, whether it's Python or something evil like Perl or whatever it is, doesn't matter. I mean code in general, right? But you know, and I do think the scripting languages we have that deal well with language, right? That have regular expressions and things. It's thrilling, really, what you can do. Okay, and we should just talk about regular expressions one day. Okay, I know, we should. Has people seen that in regular expressions like in some programming thing? Where'd you see it? Or just like? Okay. Okay. So that was with some hope that it's better. Okay, that's good to know. But it's just such a vast array of possibilities. Okay, so these slides weren't like properly up. We've just done this Murray's Law business, which was super cool. Church of Quarterology. This is what I've talked about in POX, but I'm putting it here because it's part of it. I think I may want to still race through it because it's not go through the whole thing again, but I just want to touch the main points to remind you of where that all works. All right. Excitement. So yeah, the recording insanity. This is so nice, this little thing here. See if I want to make another one. See, that's really good, right? It's a text file gone mad. Okay. And now I have to fix it. Yeah, that's good.